We'll be speaking about fields later on in other topics, but just a quick side note about uniform fields and non-uniform fields. With gravitational fields, we've got examples of a non-uniform field. With a non-uniform field, it means that the spacing between such lines is not constant. In fact, the spacing is increasing as we move further out. Here would be an example of a uniform field, which we'll speak later on in another topic, which would be an electric field. And it could be set up between two metal plates that would be charged differently. For example, one would be positively charged and the other one would be negatively charged. And in this particular case, the lines of force are defined as being the path taken by a positive charge if it is free to move in such a field. In fact, it is being repelled away from the positive plate but attracted towards the negative plate. Now, what are the main differences between the two apart from the spacing? We generally refer a lot to the term density, the density of the field. A field is more dense when the lines of force are closely packed. Okay, so with a radial field, you've got a variation in density. The lines here are closer to the surface. The lines of force are closer to one another than, say, out here. Okay, so as we move further out, the density is decreasing, and the density gives us an indication of the field strength. So it's the amount of pull that mass experiences towards the other mass. So where there's low density, that means there's not going to be that much of a pull towards the other mass. There's going to be less field strength. So that means that as the density decreases as we move further out, then the pull due to gravity will decrease. And that is very typical of a non-uniform field, where a non-uniform field, such as a gravitational field, in this particular case it's called a radial field, the density decreases, therefore the field strength decreases. What's particular with an electric field, say, set up between two such plates, is that the spacing all throughout this path remains constant. And that means that the density of the flux lines remains constant. The amount of flux lines per unit area remains constant. And a constant density means a constant field strength. That means a constant pull. And with a constant pull, say we put a positive charge here, positive charge there, that positive charge will experience a force F there. When it gets to the center, it will still be experiencing the same amount of force towards the negative plate. And when it's going to hit, just before it hits the negative plate, it is still experiencing the same amount of force. And that is very different than what happens with radial fields, where a mass here experiencing a relatively small force. As it gets closer, that same mass experiences a relatively larger force, and it will experience the largest force just before it hits the ground. So the force is constantly increasing as it moves towards Earth.